So I'm going to run a quick experiment where I take a gas pressure sensor and a syringe filled with air and measure how the pressure changes within the syringe as the volume changes. So what I'm going to do is I'm going to make a connection here, possibly just that one, and you'll see that, maybe you can see, I'm at 5 milliliters. And then what I'm going to do is attach the other end of this cable to the to Logger Pro, and I'm going to start recording, and then I'm going to begin to pull this out. So I'm going to increase the volume to maybe 7, then 10, then say 12, then 15, we're at 15, then go out to 20. So I'm going to keep changing this, increasing the volume, and we're going to look at how the pressure changes. So what I want you to do, before I do this experiment, so I want you to make a prediction. Draw the graph of pressure versus volume. What would that graph look like as I extend this out so the volume is increasing? What is happening to the pressure, and what is the shape of that graph? All right, so pause the video, draw that, and then come back and I'll take the measurement. Okay, I hope you made your prediction. If you didn't, shame on you. Pause the video again, go and do that. But assuming you did make the prediction, let's do the measurement. So I've attached the syringe to the pressure sensor, and we see that the pressure currently is reading about 100.08 kilopascals. There you go. You can see that pressure value. So 101.3 is typical atmospheric pressure, but a lot of rain today, so it looks like we have a weather system coming through, and that's affecting the pressure. So what I'm going to do is I'm going to change quickly the settings here so that I can run this experiment with an event. So we're going to say volume. I want to see how the pressure changes with the volume in milliliters. So hit the start key, and first data point is at 5 milliliters. So I enter that. All right, and now I'll begin to extend this back. So next I'm going to pull this to 7, then to 9. I was going to go by 2s. Seems like a nice, easy one to go by. So 11. It's getting harder and harder for me because it kind of wants to pull back in again as I'm extending it back out. So we're at 13, 15, 17, and 20. Let's go jump to 20 now. And let me scale on this. I probably should have done that before. But okay, so you can see the shape of this is an inverse. Now, if you're anything like most of the students who make this prediction, typically the prediction is a pressure going down as volume increases. That's usually correct. But usually folks draw this as a linear relationship, as a straight and negative line. And that can't work mathematically because, well, we know the ideal gas law is pressure times volume equals nRT. Okay, so if we rearrange this relationship to show pressure versus volume, what we know is that, well, pressure is on the left side, volume is on the right. So we would have a 1 over volume on the right side. So that right there tells us pressure is proportional to 1 over volume. That's an inverse relationship. That is not a relationship that pressure is equal to some slope, some negative slope times V. That would be what the graph would have to look like for a negative straight line. But instead, we're seeing this inverse relationship, which goes along with pressure being proportional to 1 over volume. And then the meaning of the slope here would be N times R times T. Okay, so hopefully that makes sense. I wanted to make sure you had a chance to see this video before going into talking about pressure volume loops, because I'll be referencing this particular result for that.